The Soyuz 11 crew. In 1971, 3 Soviet cosmonauts launched on a mission that seemed destined to be remembered as a historic achievement. On board were Georgy Dobrovolsky, Vladislav Volkov, and Viktor Patsayev. Their mission was to reach Salyut 1, the first space station in human history. After a successful journey, their spacecraft docked with the station. The cosmonauts entered it, becoming the first humans to live and work aboard a space station. They spent more than 23 days there. During that time, they conducted scientific experiments and proved that humans could survive in space for long periods. Everything seemed to be going perfectly. Then came the time to return to Earth. The cosmonauts left the station and entered the Soyuz capsule. The spacecraft separated, and the journey home began normally. But just minutes before re-entering Earth's atmosphere, something happened that no one expected. As the spacecraft's section separated, a small pressure equalization valve accidentally opened. It was designed to open only after landing, but air began rapidly escaping from the capsule into the vacuum of space. Within seconds, the pressure inside the capsule began dropping to fatal levels. The cosmonauts were not wearing spacesuits. The capsule was too small to fit 3 people wearing them. The crew tried to reach the source of the leak, but there was not enough time to save themselves. In less than a minute, all 3 lost consciousness due to a lack of oxygen. Meanwhile, the capsule continued its journey alone. It entered Earth's atmosphere, its parachutes deployed, and it landed exactly as planned. When the rescue teams arrived, they expected to welcome heroes returning from a historic mission, but when they opened the capsule's hatch, they found all 3 cosmonauts sitting in their seats. Their seatbelts were still fastened. There was no sign of an explosion, a fire, or a crash. The capsule appeared completely intact, but the truth was shocking. All 3 had died after the capsule lost pressure, exposing them directly to the vacuum of space. After this disaster, the design of Soyuz spacecraft was changed. Wearing pressure suits during launch and landing became mandatory, and to this day, Soyuz 11 remains the only incident in the history of spaceflight in which humans died as a result of direct exposure to the vacuum of space. The Challenger disaster. On the morning of January 28, 1986, millions of people gathered in front of their television screens to watch the launch of the Space Shuttle Challenger. The mission was historic because it carried the first teacher into space, and everyone believed they were about to witness a moment that would change history. There were 7 people on board, each with a different role. But the person who captured the world's attention was teacher Krista McAuliffe, who was preparing to teach the first lesson from space. Millions of students watched the launch live, waiting for the first classroom lesson to be taught from beyond Earth. After the countdown, the shuttle launched successfully. It rose into the sky as the crowd cheered, and everything appeared to be going normally. But just 73 seconds later, something happened that no one expected. The shuttle broke apart in the sky, turning into a massive fireball in front of millions of viewers. All 7 crew members lost their lives. In a single moment, everything was gone. A celebration turned into a global shock. The commentators were left struggling to explain what had happened, and the event became one of the most famous and tragic moments in the history of space exploration. After the investigation, experts discovered that the cause was not an engine failure or a problem with the guidance system. It was a small rubber seal called an O-ring, which was responsible for preventing hot gases from leaking out. But because of the extremely low temperatures, the O-ring lost its flexibility. Hot gases escaped, damaged the external fuel tank, and caused the shuttle to break apart. The investigation also revealed that some engineers had warned against launching the shuttle in such cold weather. They believed the low temperatures could cause the O-ring to fail. But their warnings were not taken seriously enough, and the decision to launch was made anyway. After the disaster, NASA suspended all space shuttle flights for more than 2 years. The solid rocket boosters were redesigned, and major changes were made to safety procedures to prevent another tragedy. The Challenger disaster became one of the most tragic events in the history of space exploration, but it also led to major improvements in safety standards and helped save the lives of many astronauts in the years that followed. The Columbia disaster. On January 16, 2003, the Space Shuttle Columbia launched on a 16-day scientific mission. During the flight, the crew conducted dozens of experiments, and everyone expected them to return home safely. But the disaster had actually begun just seconds after liftoff. Only 82 seconds after launch, a large piece of insulating foam broke away from the external fuel tank and slammed into the shuttle's left wing at high speed, creating a hole in its leading edge. At first, no one realized how serious the damage was. Days later, engineers reviewed the launch footage and clearly saw the moment of impact. But NASA management believed the damage posed no serious risk, so the mission continued as planned. The crew had no idea that this impact would ultimately cost them their lives. After completing the mission, the shuttle began its journey back to Earth. As it re-entered the atmosphere, superheated air entered the left wing through the hole. Within minutes, the internal structure began to melt. Then, the sensors started to fail, and their readings disappeared one by one. Soon after, the pilots lost control of the shuttle. Just seconds before the disaster, the commander sent his final message. Then, the signal suddenly went silent. Moments later, the left wing broke apart. The Space Shuttle Columbia then disintegrated at an altitude of more than 60 kilometers. All 7 crew members lost their lives. Thousands of pieces of debris were scattered across Texas and into Louisiana. Search teams spent more than 3 months recovering the wreckage. Investigators later reconstructed thousands of pieces and discovered that the disaster had been caused by the hole created by the foam strike during launch. The investigation also revealed that the problem was not only technical. Warnings from some engineers had not been taken seriously enough. After the disaster, NASA introduced much stricter inspection procedures for the Space Shuttle program. Every shuttle was carefully inspected before being cleared to return to Earth. And so, a small piece of foam that no one believed could be dangerous became the cause of one of the worst disasters in the history of space exploration. Apollo 1. On January 27, 1967, 3 American astronauts were preparing for the first crewed mission of the Apollo program. The program NASA was counting on to reach the moon. The crew consisted of Gus Grissom, Edward White, and Roger Chaffee. But here's the strange part. The disaster didn't happen in space. And it didn't happen during launch. It happened while the spacecraft was still sitting on the launch pad. That day, the crew was carrying out a routine test, known as the plugs out test. The purpose of the test was to make sure the spacecraft could operate using only its internal systems, without any external power source. The rockets weren't firing, and there were no plans to launch. Everyone thought it was just a normal test, but inside the capsule there was a deadly danger. The cabin was filled with pure oxygen under high pressure, and that meant even a tiny spark could turn into hell within seconds. Suddenly, Mission Control picked up the voice of one of the astronauts shouting. In less than 5 seconds, the flames spread throughout the entire cabin at an incredible speed. Because of the pure oxygen. The crew tried to open the capsule's hatch, but the design was far too complicated. The hatch opened inward, while the rising pressure inside the cabin made it impossible to open. The astronauts were trying to escape, but with every second the heat grew more intense, and the smoke became thicker. Outside, the rescue teams rushed toward the spacecraft, but they couldn't reach the crew quickly because of the intense flames and toxic smoke. It took several minutes to open the hatch, and when they finally managed to open it, it was too late. All 3 astronauts had died inside the capsule. The main cause wasn't just the burns, but also the toxic gases they inhaled, and the suffocation caused by the fire. The disaster shocked the entire United States. NASA was preparing to send humans to the moon, but it had lost 3 of its best astronauts before the spacecraft had even left Earth. After the investigation, engineers discovered that several factors had caused the disaster. These included the use of pure oxygen inside the cabin, along with a large amount of flammable materials. There were also electrical wires, believed to be the source of the first spark. Because of the accident, NASA suspended the entire Apollo program for several months. Then the capsule was completely redesigned, and many of the flammable materials were replaced, and the spacecraft's air system was changed, and a new hatch was designed that could open outward within seconds. Because of these changes, the Apollo program was able to return. And less than 3 years later, Apollo 11 successfully landed the first human on the moon, Soyuz 1. On April 24, 1967, the Soyuz 1 spacecraft launched into space with Soviet cosmonaut Vladimir Komarov on board. The Soviet Union wanted to prove to the world that it was still moving ahead in the space race, which made this mission one of the most important at the time. But sometime before the launch, a group of engineers had discovered dozens of problems with the spacecraft. Reports showed that there were many technical issues that could put the mission at risk. Even so, the launch wasn't delayed and the spacecraft took off as scheduled. As soon as Soyuz 1 reached orbit, problems started appearing quickly. One of its solar panels failed to open, cutting off a large part of the spacecraft's electrical power. Then another problem appeared. Because the spacecraft was unbalanced, it became difficult to control its direction. Komarov could no longer easily point it toward the sun to charge the batteries or keep it stable in space. While Mission Control was trying to find solutions from the ground, Komarov spent long hours inside the spacecraft, following instructions and trying to deal with the failures. But every attempt seemed to reveal another problem. Eventually, the officials decided to cancel the mission completely and bring the cosmonaut back to Earth as quickly as possible. But the return wouldn't be easy. With several systems failing, Komarov had to perform a complicated re-entry maneuver. He managed to guide the spacecraft back into Earth's atmosphere successfully. For a moment, it seemed like the danger was finally over, but When the spacecraft reached the point where the parachutes were supposed to deploy, something happened that no one expected. The main parachute deployed, but it didn't open properly. Then the system tried to deploy the backup parachute, but it became tangled with the main one, causing it to fail as well. Within seconds, the spacecraft was falling toward Earth with nothing to slow it down. It was falling at a speed of more than 700 kilometers per hour. Moments later, the spacecraft crashed into the ground with tremendous force. Then, the remaining fuel inside caused it to explode, turning it into a burning pile of wreckage. When the rescue teams arrived at the crash site, they found a large crater and burned wreckage scattered across a wide area. The impact was so powerful that identifying the cosmonauts' remains was extremely difficult. After investigating the accident, it was determined that the main cause of the disaster was the failure of the parachute system, along with several technical problems that had affected the mission from the beginning. The disaster led to the Soyuz program being temporarily suspended. The spacecraft went through a complete review, and many of its systems were modified before another crewed mission was allowed to launch. And so Vladimir Komarov went down in history as the first person to die during a space mission. His story became one of the most tragic disasters in the history of space exploration, and it also helped improve safety standards that saved the lives of many astronauts in the years that followed. X-15. On November 15th, 1967, American test pilot Michael Adams was preparing for his 7th flight aboard the X-15 rocket plane. This was no ordinary aircraft. It had been built to reach the edge of space and test both human limits and aircraft performance at extreme speeds and altitudes. Because its rocket engine burned through fuel incredibly fast, the X-15 couldn't take off from the ground like a conventional aircraft. Instead, it was carried beneath the wing of a massive B-52 bomber and released at an altitude of about 13 kilometers. Only then would the pilot ignite its rocket engine and blast toward the sky. At 10:30 a.m., the X-15 separated from its carrier aircraft over the Nevada desert. Adams ignited the rocket engine at full power, and the aircraft began climbing at an incredible speed. But during the climb, an electrical failure affected some of the flight control and navigation systems. Adams still had backup systems, so he decided to continue the flight. Just 3 minutes later, the aircraft reached an altitude of nearly 81 kilometers above Earth's surface, high enough to be considered space under the standard used by the U.S. Air Force. At that moment, Adams was flying through a very unusual region. The air was so thin that the aircraft's normal control surfaces were no longer effective, so it had to rely on small reaction jets to control its direction. At the same time, he had to perform a wing-rocking maneuver so that a camera mounted inside the aircraft could capture the horizon. But the maneuver became much more violent than planned, and the aircraft gradually began to drift off course. By the time it reached the highest point of the flight, it had already deviated by about 15 degrees. Then it continued drifting until it was descending in a completely different direction from its original flight path. Adams reported to Mission Control that the aircraft had become unstable. The X-15 was spinning violently while traveling at more than 4 times the speed of sound. Meanwhile, Mission Control tried to help him, but there was no solution to the problem. With great difficulty, Adams managed to regain control of the aircraft, but it was too late. The X-15 had flipped upside down and was plunging toward the ground at tremendous speed. As it entered the denser layers of the atmosphere, the aircraft was subjected to forces far beyond its structural limits. It broke apart in midair, and the wreckage crashed across the desert, bringing Michael Adams's flight to a tragic end. After the investigation, it was determined that the accident had been caused by a series of failures in the navigation and flight control systems, making it the only fatal accident in the history of the X-15 program.